ladies and gentlemen, we're going to add stuff to our circle book about tangents. So I would go to a new page of your circle book. So I've got, like one page has the diameter, radius, stuff on it. The next page has things about area, circumference, exact, and equations of circles. We're going to go to a new page for tangents. This is all about tangents. And we're going to add a few other things in there as well about secant and stuff. Okay, so first, a tangent touches a circle at exactly 1 point. So we're going to draw a picture of a circle. We got a point and we've got a line. That's a tangent. Touches a circle at 1 point. Yeah. Touches, you should write this down in your circle. Nobody's phone should be out. You should all be writing this down. Touches a circle at 1 point. Guys, put your phones away. Get your circle book out. If you can't find your circle book, write this on a piece of paper. Okay? Tangent touches a circle at 1 point. Okay? We've got a circle. We've got a tangent. Also, the tangent and the radius meets at 90 degrees. So a radius meets a tangent at 90 degrees. Anna, will you pull the door shut for me? Okay. So we've got those two important pieces of a tangent. Probably the most important. Then if we've got two tangents that meet at this exterior point, they are equal to each other. So tangents that meet at the same exterior point are congruent. And then we've got a circle that's kind of surrounded by tangents. Yep, I will. Tangents that meet at the same exterior point are congruent. Okay. And then if we've got a circle surrounded by tangents like this, we can say AB plus DC equals AD plus BC. Okay. Trying to read sideways is not your thing, huh? All right, we got some more. Now, if we have two circles, they can share a tangent. So we're going to draw some pictures of those. So I'm going to make this go away. I've got two circles. And they can share a tangent, and that's called they'd be both touching it though. This is called an internal tangent. And you can also have two circles have an internal tangent going like this. They can share tangents. This is also internal tangents. And you can have two circles that have external tangents. Internal goes in the inside, external's on the outside, right? Here's another external tangent. We could have a circle with a circle inside of it, with a line going on it. That's still an external tangent. Can this circle have any tangents that they share? These two circles? No, because a tangent can only touch a circle in one spot, so it can't go through it. Just touches it at one spot. Okay, and we're going to add one thing on this page that has nothing to do with tangents. It's called a secant. So a tangent touches the outside of a circle at one spot. A chord is inside a circle, right, and hits two spots. And then we've got, this has no tangents. And then we've got this thing where so tangent touches the circle at one spot. A chord would end, the end points would be on the circle. What about a line that goes through the circle? That's called a secant. It intersects a circle in two spots. Okay, so if we look at your packet for today, okay, we've got a bunch of different things on here. The second page is much easier than the first, so I'm going to do one of the problems on the first page. I'm making this go away. I will put up all your circle book notes again when I'm done, if you'd like it. Okay, so I'm looking right here. Let's look at number 3. O has a radius of 8. P has a radius of 3. And the distance between this radius between OP is 13. And we want to find the measure of the common internal tangent. So the distance straight between them is 13. So not that tangent line, but the distance between them. So what we're going to do is we're going to say this is 3. This is 8. Okay. We're going to say that the distance, this is an internal tangent. Okay. And we're going to say the distance between them is 13. So this shouldn't say internal, this should say external. And then this picture is off because it should be out here. We want to know that distance. So I'm telling you between O and P, this distance right here, straight across between O and P is 13. Okay, so what we're going to do is we're going to create a right triangle, and then we're going to create a rectangle. So if I want to make this into a rectangle, I'm better off showing you down here. Okay. This is 3, this is 8. If I took this and cut this off, do we agree that this top part, if O and P is 13, if I make this 3 and this 3, this can be 13 too because they meet at 90-degree angles. Okay. So then I have created a right triangle right here. where this distance right here isn't 8 anymore. 8 minus 3 gives us 5. So you see how we have this right triangle at the bottom? So we end up with this right triangle that looks like this, where this is 5, this is 13, and I'm going to try to find x. So then I'm just going to go x squared plus 5 squared equals 13 squared. And I'm going to get x squared plus 25 equals 169. Subtract 25 from both sides. X squared equals 144. And so x equals 12. Okay. So it's basically you're figuring out where that right triangle is. Almost all of this you have to do Pythagorean theorem to get. Okay. All right, so you're going to attempt the rest of this. Going to work on the rest of this packet. You are going to get it done, I think, by the end of the day tomorrow. I might have to add some more notes for tomorrow's. And then we're going to move on to arcs and angles. Square angles. Okay.